Hey everybody, I'm meteorologist Gavin Sandell. Well, the closeness between two Atlantic tropical systems may end up triggering an unusual atmospheric dance party. It's called the Fujiwhara effect and it was coined back in 1921 by a meteorologist in Japan, Sakahue Fujiwhara, and it actually describes the phenomenon where two cyclonic vortices move around and interact with each other. That's a lot of meteorological jargon, but basically you have one low pressure here, a second one here, and when they get a little bit close, then the movement and stuff starts to get erratic. There's three scenarios of when that occurs, which I'll talk about in just a moment. But let's talk about the suspects and why this is. On your left side, you could see Tropical Storm Imelda, currently as of Monday afternoon, and on the right side, that's Hurricane Humberto, a Category 4. And those systems are just shy of 600 miles apart from each other, and they've gotten closer as the day has happened. And while that does seem like a lot of distance, 600 miles in hurricane terms is not a lot. You need 900 miles of separation when you have two large storms to really get this Fujiwhara effect going, but for smaller storms, you need 400 miles. So, it's not like you're following a book, you're following rules. Things can change a little bit when you have this. So let's talk about these three scenarios of what could happen. And the first one is going to follow a theme that I'll talk about too. You have two storms here, one north and one south, and they're going to follow my finger here. They're going to follow an imaginary point, and that's the whole substance of the Fujiwhara effect. They kind of rotate around, and depending on what happens afterward with the environment, then that is your impact. So in this first scenario, you have a weaker storm that typically fizzles out due to maybe some shear, maybe some colder water. The second scenario takes it pretty similar. You have a strong storm and a weak storm, and you also have that rotation along my finger until the weaker storm gets kind of absorbed by that larger storm. So those are two of the same kind of things, just different end games. The third one kind of thing puts things a little bit differently. You have now two stronger storms, and kind of like if you were to put the similar poles of magnets together, like a North Pole and a North Pole, these hurricanes in this third scenario would repel from each other. And again, we're not exactly sure of why this is with the Fujiwhara effect, but it is still something that we do see pretty uncommonly in our area. And for this reason, the tropical cyclone track of Imelda has been a little wishy-washy. You remember from Friday when it was first going to be named, we thought it was going to impact the Carolinas and make landfall as a hurricane. But now that we figured out that this interaction wasn't going to be as pertinent, now that a high pressure ridge was going to shift to the south and bring it out, now we know that it's going to move towards the east and past Bermuda as well. So I want to end this off by talking about a famous case that happened in the eastern Pacific, closer to California. These are two hurricanes right here, Hillary and Irwin. Irwin on the left and Hillary on the right. And you could see here when they're moving, they do that rotation, that counterclockwise rotation because we're in the northern hemisphere. And it ended with Irwin fizzling out just because it got into some cooler water and some higher shear as well. So for Humberto, this is actually coincidentally not the first time a storm with that name was involved in a Fujiwhara interaction. It spun around the western Atlantic with Hurricane Iris back in 1995. For Weather 101, I'm Gavin Sandell.